This video will focus on piecewise functions, but first I just want to remind you that domain represents the x values where a function is defined, and range represents the y values where a function is defined. A piecewise function is a function that is a combination of one or more functions. And there's going to be a rule for a piecewise function that's different for the different parts or the different pieces of the domain. So pieces is why we call it a piecewise function. The first thing we're going to do is we're just going to evaluate certain x values in piecewise functions, and then we're going to take a look at graphing them. So for part A and for part B of example 1, we're going to evaluate each piecewise function for x equals -2 and x equals 5. So first, starting with the function evaluated at -2. That's how I read this. F of -2 means the function evaluated at -2. I have 3 different functions. I want to use the one where x is -2. So for -5, that's for all x values that are less than or equal to 0. Well, -2 is less than 0, so I would use the function -5. If there were an x value in this function, I would plug in -2 for x, but because there isn't, I just know f of -2 is -5. Now the function evaluated at 5. So -5 was for all x values less than or equal to 0. This no longer applies because 5 is greater than 0. I would use 4 if x is between 0 and 3. Well, 5 is not between 0 and 3, so that one doesn't work. And 12 would be if x is greater than 3. Well, 5 is greater than 3, so I would want to put a 12 there. Part B, g of x, but it's the same process. We have 2 different functions this time, one of which we would use when x is less than 5, the other is greater than or equal to. Starting with -2. -2 is less than 5, so I want to use the 3x plus 4. But in place of x, I'm going to put -2. This is using substitution. I'm substituting in a -2 where I see x. And that gives me -6 plus 4, or -2. F of 5. So the function evaluated at 5. 5 is not less than 5, it's equal to 5. So I want to use this one, saying x is greater than or equal to 5. And I'm substituting in a 5 wherever I see an x. So it's 5 squared minus 3, which is 25 minus 3, or 22. All right, that's evaluating piecewise functions. Now we're going to try and graph them. For part A, we have 2 different functions for 2 different domains. The first one is f of x equals -4. F of x just means y, so really this is saying y equals -4. I'm just going to write this in pencil. You don't have to draw this part unless you want to. But y equals -4, 1, 2, 3, 4. You go down 4 and draw a horizontal line. So this is y equals -4. However, I don't want to use this whole function. I only want to use the part where x is less than 2. This is my domain restriction. So x and 2 is right here. This is 2 on the x-axis. I want it for x is less than 2. So I want the left-hand side of the graph all the way until I get to 2. Now it is strictly less than, so I'm going to use an open circle, because an open circle means it is not included in my domain. So an open circle. My second function is y equals 4. This is a positive 4 this time, so I'm going to go up 4, 1, 2, 3, 4, and I'm going to draw a horizontal line. Now, I don't want to use that whole function. I only want to use the part on my specified domain. So when x is greater than or equal to 2, so here's 2. I want the right-hand side because these are the x values that are bigger than 2. And it says greater than or equal to. So that means 2 is included. I want to use a closed circle here. Closed circle for when it's included. So we would do that when we have equals, greater than, or less than, or equal to. So greater than or equal to or less than or equal to is what I meant to say. And we use the open circle for less than and greater than. Okay, let's try part B. So we have y equals 5, so 1, 2, 3, 4, 5. That's right here. Now I don't want to use this whole function, I just want to use the domain. So from 0 to 4. So here's 0 and here's 4. There's no or equal to sign, so that means they are not included, and I'm going to have to use open circles. The second function is 9. So here's y equals 9 right here. And that's for 4 to 18. So I'm realizing now I'm using a scale of 1. It may have been easier for me to use a scale of 2, but no big deal. I'll make it work. I'm just going to extend it and say, hey, 18 is going to be right out here. So from 4 to 18, here's 4, and that's about where I put 18. Now 4 has the or equal to, so this is going to be a closed circle, and the 18 does not, so that's going to be an open circle. And the third function is at 6.5, so y equals 6.5. Is right there, up 6.5 units. So that's y equals 6.5. And I want to use this for greater than or equal to 18. So there's going to be an open circle, and if it's greater than or equal to, I want the x values as they increase. So the purple functions is my final piecewise function. That's what I'm looking at here. It's just easier for you to graph the functions and then erase what you don't need, or use a different color to specify what your piecewise function is. So if I wanted to, I could have just went through and said, okay, I don't need that anymore. There's my piecewise function right there, just so it's not so crowded. Okay, next, I'm going to continue to graph the function and then just erase what I don't need, or use a different pen to denote what I need. First, I have y equals x plus 4. So this is our linear functions, what we reviewed in the previous video. My slope is 1, and my y-intercept is 4. So here's my y-intercept of 4. And I have a slope of positive 1. So up 1, right 1, or down 1, left 1. And that's going to give me just the general shape of my function. And I want it for x is less than -2. So because it says less than, I know I want an open circle. And -2 is right here. So I need to find where the function is at -2, which is right here. And I said an open circle. I want to shade the part that is less than -2. So that would be the left-hand side. If you wanted to, you could go ahead and erase the part we don't need anymore. This is the part of the piecewise function right here. And then for the second equation, here's my slope, and it doesn't have a b, so I know that it's 0, meaning it starts at the origin, and the slope is -1/2, so down 1, right 2, down 1, right 2, or up 1, left 2, up 1, left 2. Plot as many points as you need to get a good line. I'm very bad at drawing lines, as you can tell. And then it's when x is greater than or equal to. So because it says or equal to, we're going to have a closed circle where we see our function. Here's -2. Here's my function. I'm going to have a closed circle that's included. And I want to use the right-hand side because these are the x values that are greater than -2. And I can erase the part I no longer need. So there's my piecewise function. Part D. Once again, we're using y equals mx plus b. The slope is 3. The y-intercept is 8. So I went up 8. And then slope is technically over 1. So it's up 3, right 1. Or I could have gone down 3, left 1. So I'm going to do that a couple times. Down 3, left 1. Down 3, left 1. Down 3, left 1. Down 3, left 1. I'll do it one more time just to get a good view of what's going on here. So it's less than or equal to, so closed, of -3. 1, 2, here's 3. The function's right here. And because it's less than, I want the left-hand side of the graph. Meaning I don't need this mess anymore. The second function is -2x, and then I have no plus b, so that's technically plus 0, meaning I'm starting at the origin, and then I have my slope of -2, so down to right 1 or up to left 1. You can plot as many points as you like in order to get the general shape. The more points, the better, because then you have a nicer line. And I want it from -3 to 1. And both of them are going to be open circles because they don't have the or equal to's. So -3, the function's right here. I'm going to put a open circle there. And then x equals 1 is right here. So another open circle. And I'm going to connect those two circles and erase what I don't need. Last function is x minus 3, so the slope is 1. Intercept is -3, so 1, 2, 3 right there. And just plot your points using the +1 slope to get a general line. It looks something like that. Now this is going to have a closed circle, and it's going to be for greater than 1. So here's my greater than 1. It's the right-hand side. And I'm going to go ahead and close the circle. I know it was supposed to be open from the previous one, but it's closed now because of the third function. Oops. Just ignore that little splotch there. But there's my piecewise function. I want you to cross off example 3, and you're also not going to do number 5 or number 6 on the homework. But please try the try problems and hit play when you're ready to check. Feel free to pause the video and check your work here. So the purple are what your piecewise functions should look like. And then there's 3. Again, feel free to pause and check your work.